So, last class we talked about just multiplying these rational expressions. Today we're going to be dividing them. So we're doing the dividing piece today. Now I want to remind you guys about dividing fractions. And you might not even know this or remember this because maybe you just put your fraction into your calculator. I said not to put this into a calculator because I want to remind you guys how to do a problem like this without a calculator. The reason for that is because when we add variables to it, you can't put that into a calculator anymore, so you have to know how to do it by, say like by hand or in your head. So what's the rule for dividing fractions? So like number 2 in our warm-up. Do you guys remember? Yep. Keep, change, flip. And what that means, so, and you might have heard it as keep, flip, change, but I like keep, change, flip. It makes more sense to me. So we keep this as 8 over 21. We change the division to multiplication, and then we flip the second fraction. So all we do with division of fractions is we just change it to multiplication. Kind of like, I don't want to do that, I'm going to do multiplication instead. So we get to change that. There's not really a way to divide fractions other than changing it back to multiplication. Now again, I like to cross cancel. I don't know your preferences on that, because if you had to multiply this, this would be some big numbers. This would be 72 over 210. Then we'd have to simplify. What I like to do first is simplify. So I'm going to simplify 9 and 21 by 3, 8 and 10 by 2. So I'm left with 12 on top of 35. So 4 times 3. So I'm assuming we can divide these by maybe 6 to get 12 over 35. So knowing how to do that is super important, because if you're like, oh, I just put that in my calculator and the calculator does its magic and I get 12 over 35 and you have no idea where that, like how that happens, it's like we need to make sure we're understanding that we have to flip that second fraction. Now this last one here looks crazy. It's a fraction within a fraction. All this is division. So again, we're going to keep the first fraction, change it to multiplication, and flip the second fraction. And again, I don't want to multiply 16 by 9. I would rather simplify a little bit. 16 and 14 can both be divided by 2. 9 and 3 can both be divided by 3. And so now we're ready to multiply. So 8 times 3 is 24. 1 times 7 is 7. And we're fine with improper fractions, so you don't have to change that to a mixed number. And so again, your calculator obviously is a great tool, but if you're not learning kind of some of the basic skills, some of these types of problems can get difficult for us. So we're going to flip the page over, and we're going to go into division with this. So what we're basically doing is doing what we did last class with the multiplication, but we're just going to have to change it to multiplication first. So when we see a problem with division, immediately changes to multiplication. So today is almost the same, except for that very first step, which hopefully doesn't stumble up too many people here. So again, all these division, I'm just going to say let's change it to multiplication. So every single problem, we're just going to change it to multiplication and flip the fraction, and then just work how we did yesterday, or last class. So we have 15y to the second over 6x. That doesn't change. What changes is the division becomes a multiplication, and then I flip the fraction over. Now we can do some canceling, some simplifying, looking to see what we can cancel. Remember that this really is like one big fraction. We have a top and a bottom of it. So for instance, like the 6 over 8 or 8 over 6, I can divide those each by 2. 15 and 10, I can divide them both by 5. Now I might just multiply to see where we're at right now. So I did some canceling, and some of you guys might say, oh, I can cancel more, but I'm thinking it's getting kind of jumbled. So I'm going to rewrite what I have. So I have 3 times 4 is 12. I have y to the second, x to the third on top. On the bottom, I have 6 times 2, or 3 times 2, which is 6, x and y. Now again, if you could stay organized up there and we're able to cancel some more, you're welcome to do that. You don't have to write this in between step. But now this kind of makes it a little bit cleaner and easier to work with maybe. So 12 over 6, I know that's going to be 2 over 1. The y's, there's more y's on the top, so I'm going to leave that 1 y on the top. And there's more x's on the top. There's going to be 2 more. There's going to be 2 more. What do I keep hitting? Quit. I'm putting like Google Drive somewhere with my arm. I don't know. My sleeve or something. So x to the third over x will just be x squared. So everything's on top, so you could leave it this way. Otherwise, you could just call it 2y x to the second. The order you have them in doesn't matter. If you want to put the x first, that'd be great. So again, just trying to stay really organized with this. And like I said, some of you guys, that's more of a struggle than others. So trying to make sure that we're kind of not trying to lose anything along the way. So again, keep, change, flip. For multiplication. And again, if you can cancel things right now, you're welcome to. But I see 6 over 2, or maybe we even put this all together. So let's do that. I'm not even going to cancel. So just showing you guys, if you'd rather just write it as one big fraction, that's perfectly fine. And then this kind of just becomes like an exponent problem. So 6 over 2 is going to be 3 over 1. Again, there's more d's on the top, there's 1 more. And there's more c's on the top, there's 2 more, 5 minus 3. So again, you could also write it this way. So like I said, those types of problems we could have done chapters ago. And this actually is really good for us to review because this is going to be on our exam, which our exam is in, less than 2 weeks from today. It's 2 Wednesdays from now. So knowing that these exponent rules are kind of coming back, and so kind of thinking about them is going to be helpful and important. All right, our next ones with division now become a little bit more complicated. Anytime you see the plus signs and minus signs in them, think factor. So we're going to do the keep, change, flip, but then we have to remember to factor. So we're going to keep, change, flip. And then we'll factor. And we know to do that because of the plus and minus. There's more rules that come with addition and subtraction than with multiplication and division. So in these cases. So I'm going to rewrite this. Now some of you guys who are pretty good at doing things in your head, you might be kind of doing some factoring already, and that's perfectly fine. I'm going to kind of go a little bit slower than that. So I'm going to flip this one over. Now, again, we can't just say, oh, there's an x on the top and bottom, I'm going to cancel them. We have to factor first. We have to change it into multiplication instead. So the first fraction here, the x plus 3, nothing can happen. But on the bottom, there's a GCF. We can take out a 2. And hopefully you're already like, oh, I can cancel that. Noticing those things is okay. I just won't usually cancel it until we finish kind of the whole thing here. On the next top, I can take out a 4. And on the bottom, I can take out a 3. And GCF factoring is really common in these, so just know that that can show up quite a bit. And anything that's on the top and the bottom now, we can cancel. So I can cancel these x minus 2s and these x plus 3s. On the bottom, we have 2 times 3, which is 6. But 4 over 6, I would like to simplify. I don't want to leave that, so I'm going to call that 2/3. So a lot cancels out of this. So initially that problem looked totally crazy and there was a lot going on there, but we get it down to just 2/3. Now our letter B, the second part is not a fraction. How do I make something a fraction? Yep. Put it over 1. So we're going to put that over 1. And now we'll keep change flip. So this is going to change to multiplication, and the 1's going to be on the top. Actually, sorry. Okay. Why don't you factor that in, you can? I just realized you might. I'll take it. Sorry, thanks. Bye. Sorry. They were looking for someone and we should probably take attendance. So again, we're factoring on that one. Hopefully, I'm sure you solved it all and you're on to like all the rest of them. I think we're good now. No longer on the attendance naughty list. Okay, so 6 and 9, we can take out a 3. And then on the bottom down here, the 12 and 18, we can divide those both by 6. Now, I talked about canceling up and down. We can also cancel diagonally like we did in the warm-up. So these two can cancel diagonally because they're identical. Again, I'm going to rewrite what I have. I have 3 on top. I have 6, and then I'm going to put this a plus 3 in parentheses. The reason for that is because the 6 is being multiplied to both terms, so I want to make sure that's really clear. Now the 3's can't cancel, but this 3 over 6 can simplify. So those can be both divided by 3, so we'll have 1 over 2 parentheses a plus 3. So take a minute to make sure you're okay with what I did there. Rewriting this bottom is a little bit confusing. I put the 6 in the front just because that's what we're used to seeing with those parentheses. And then I just simplified the 6 over 3 as 1/2. And the a plus 3 is still just there. And again, we can't cancel back here. We can't cancel like that 3 with the a plus 3 because 3 is being added to a. So addition and subtraction gives us those different rules that we can't really be as like Just cancel whenever you feel like canceling. All right? We'll go on to the last two questions, and you guys will have time to work on homework. It's our last brand new homework assignment of the year. The rest will be review for us. So keep change flip. So this flips over. Now this is some of that factoring that's really good for us to review as well. It's a 3-term, so it's a trinomial. This is the kind, again, I think you guys like these. You multiply to get to the one number, you add to get to the other. If you don't like them, at least that seems familiar that I've said that about 1,000 times here. So we're gonna do x and x. We'll deal with that in a second. Now, usually there's a clue in the problem. If the problems are well written, this is probably a clue. We're probably going to use x minus 1 somewhere down here. These problems are written so something will cancel. Hopefully these aren't just haphazard, random questions. They're kind of written that way. So we want to multiply to get 4, but add to get a negative 5. So obviously 2 and 2 won't give me 5. But 1 and 4 will give me 5. If they're both negative, then we get that negative 5. Or that negative 1. Or not, sorry, it should be 4. Sorry. 1 and 4. 1 times 4 is 4. 1 plus 4 is 5. They're both negative. That's how we get the negative 5, is what I was trying to say. All right, so now we're ready to do some canceling. And again, this x minus 1 can cancel with this one because they're both kind of on their own. So what's going to be on the top is the 5x squared. And again, I like writing the thing by itself, the monomial by itself first. But now hopefully you're realizing that there's some simplifying we can do with this part. So 5 over 10 is going to be 1/2. There's more x's on the top than on the bottom. There's going to be one more. And then this x minus 4 is going to have to stay on the bottom. And we can cancel those x's again because the x has a 4 being subtracted from it. Great. Last one here is some of every type of factoring that we'll see in these problems. So again, keep, change, and flip. So again, lots of factoring we can do. This first one, the 2 terms, that's that special type of factoring that's called a difference of squares. We want to multiply to negative 16 but add to 0. It's 2 terms, perfect squares. So this is going to be x and x. What's our 2 factors? Well, will give me a negative 16 but add to give me 0. So this should be an 8 down here. Yep. Negative 4 and positive 4, very good. And I don't know if you guys saw, but I wrote the bottom of this wrong. It should be 2x plus 8. I had written 3. Okay, so we have that taken care of there. Good job. So out of this, we can take out a 2. I already see some stuff that can cancel, but I also see kind of a few things going on over here. Ooh, there's going to be lots of 4s. Now this next one has 3 terms. But this time we're multiplying to get 16, but adding to get 8. So really similar question. It's going to just be 4 and 4, but positive. So I'd say this one, the toughest thing is not canceling too much. So making sure I cancel in pairs. So the pairs can cancel. So x plus 4 can cancel with this x plus 4. This x plus 4 can cancel with either of these. I'm going to go this one. Doesn't really matter. So what I'm left with on the top is x minus 4. On the bottom, I'm left with 2 parentheses x plus 4. And I know it looks like, oh gosh, we should be able to cancel those because they're so similar, but they're not similar enough. Like again, if you think about it with real numbers, if I put a 10 in there for x, 10 minus 4 is 6, 10 plus 4 is 14, those aren't the same number. So we can't just go ahead and cancel those. So this is, and again, the 4 and 2 can't cancel because the 4 is being subtracted from x. Okay? So that's all we have left. So again, for our homework, oh, I need to move this over in Schoology. I don't think it's in there. So we're finishing this assignment for Friday. We're doing the rest of this. I'll move the pages over in Schoology here for you guys.